this paper tried to identify whether a sentence is AI related or not. So basically, we want to use BERT to try to identify the category of this sentence. So let me show you one sentence for this for this sentence. So this is a complete sentence. So I try to identify what's the label of this sentence. So we use BERT to try to identify, but BERT is not a trained for AI detection test. So we have to fine tune this model first. So we have to get different kinds of training set, try to train the BERT for our AI test. So basically, this data is used for trying to fine tuning our model. Yeah. This is structure of our data. We have sentence, we have their label, but in our cases, we have to label it by maybe manually label it. So this BERT. BERT basically is a model created by this guy. Yeah, by the Yi Yang. This is one very classical paper for accounting research. This is from I remember it from Hong Kong University of Technology. So this is the how they train their model, and they share this model on as a open source way. You can download this model on Hugging Face or on GitHub, and they also have different version like maybe ESG classification task. Yeah. So basically, this code use the most basic, most classical one. It is pre-trained model. Yeah, and they also offer the ESG related model. Yeah, this is the model part. You can download any model you want. From Hugging Face, like other version like ESG version. Yeah. So for the basic BERT model, we cannot use it for training our for our AI tests. We have to fine tune it first. So we need to use the data set, try to fine tuning our model. So I will show you how to use our code to fine tune our model. Yeah, this is the code part. Yeah. I use Colab to replicate this model. Yeah, I have to upload our data set first. Let me show you. I have to upload the data set to Colab first. So you can see I have uploaded it to my computer. So here is the data where it is. So first, I imported all the library I need to run this code, like Lumpy. This is a library, some very traditional library in AI related, and I also need to import some BERT related to the library. Try to run this model. Yeah, this is basically for the BERT part and some data set, some machine learning model related library, because we want to evaluate the performance of our model. So we use some basic machine learning library. Yeah. So this is because there is a complicated version of our library. So I changed it to the library I want. So this is the torsion. So we also can see what is the version of our transformer or of our this torch library. So then when we try to load the data set, yeah, let me show you. Maybe I can run this code. Get some time. Yeah, maybe I can explain this to you first. This is the data set I show at the beginning, and this is basically what we created for fine-tuning purpose. Yeah, and minute we are trying to installing the we are trying to install the basically when you finish the loading the data set, we got a data frame. I maybe take some to load it. Yeah. We can see the structure of the data set. Then we try to split the data set into some training data set and some test data set, and we try to also get some validation data set. So here is a percentage. The test size is 10%, and the test size is 10%. So we can see this is what the data set like. We have the sentence, we have the label, yeah. And this is distribution of our training data set and the test data set and the validated data set. So we can see here is the rows, here is the rows, here is the rows. Yeah, the number of the rows. Yeah. And here I use some online version of the model because the Google doesn't provide any GPU as I don't want to upload the data from my local, so I use some online version. This is also a ThinBird, so I just use this model, try to for our classification task. So first we have to define what kinds of model we want to use. So I use the FineBird pre-trained model, and then I try to appoint the deliver the parameter to our function, and this is how we can run our BERT model, and this is the model name, and then we try to use the tokenizer, uh, the tokenizer is a function try to maybe tokenize our sentence because the sentence is text. We have to transform it to maybe some words and some vectors. So this is what the tokenizer doing. Yeah. So after the tokenizer, we try to uh, clean our data set because our data set is, as you can see, the sentence is are not the same data set because some are have a more words like 200 words, maybe some only have let me show you, maybe only have six words here, but some is very long. Yeah, so we have to standardize our data set. So this is basically what this function doing. We try to giving the dataset a max length. This max length is 128. So after this, we can get a better data set. So then we try to deliver this data set to our model. And we also want to evaluate our performance of this model. So basically, here is the evaluation function. And basically, we just want to see the outcome from this model and compare it to the real label we input here. Sorry, is this very much? We want to compare the output of our model and the label we created. So we can use this as a evaluation matrix. Yeah, this is what the compute matrix doing. Then we try to deliver some parameter to our model. Here is some basic parameter for the model. This is like the learning rate, like the EBCOS. Like EBCOS means how many rounds we want to have for our model, and maybe some decay rate. You can maybe find some the definition of this parameter in their model part. So if you want to change some parameter here, you have to go to the guidebook first, then change it. Yeah. Then we use the trainer function. Remember, we have defined our model first. Our model is ThinBird. Yeah, here. And we directly input to our trainer part, and our parameter we define here. So we directly input it. And we also have split the data set to training data set and validation data set. So here is our data set. And we also get our evaluation method. Yeah, here is the evaluation function we define here. So we can directly run it. Let me show you. Okay, here is our data set, and we try to define what kinds of model we want to use. Mhm. Okay, we have already successfully run our model here. So we go to the dataset part. Yeah. So this function is used to try to limit the length of our sentence. So maybe I can show you. Oh, okay. Yeah. Yeah. Here is the define. Here we try to define our parameter. Yeah. We finish this. Then we try to run our model. Yeah. This is just a maybe deliver some parameter to our data set. Then in this part, we try to run our model, but it takes 1 hour to run this task. But if you only using your CPU, because Google doesn't provide the better maybe like GPU stuff. So we have to run it locally. So it takes 1 hour to finish this task. So maybe I just show you. You can see the result first because I use different models. So maybe the accuracy is not so perfect. But I think the model Professor Ryan using is better than me. So I can just show you the result. Now I'm running the BERT model. Yeah. Okay. It needs my API. Maybe I can do. Okay. It doesn't matter because this is just a tracking function. Try to see what is the process uh like during the training stage. So maybe I can ignore this. I can directly show you the result. Mm. Basically, you can see the process of this training stage. You can see how long time you still need to waiting for, and you can see what is the accuracy for the first epoch and the second epoch and the third epoch and the first and the fifth, and you also can see the maybe some parameter for this model. Yeah, this is this is kind of different from the what is Professor Ryan provides to me because I run it on Colab. Colab is online platform. So I also try to replicate this code into a local method using a local method. Yeah, let me show you. Yeah, this is the same code from I just showed you before, and I just try to run it locally. And also, when we finish the training process, we got a fine-tune model. So for next time, we want to try to identify whether a sentence is a AI related or not. We can directly use our fine-tune model. So we use the sieve model. Then a save model function try to save our training model. So we get a training model here. For next time, maybe you can just directly import your train model here to finish your task. Yeah, yeah. And Professor Ryan also provide a AI maybe some dictionary method. This is very classic method in text mining in accounting research. So basically, they try to go over all the data set, try to identify whether we have these words in the sentence, like machine learning, like big data. Yeah, I think I finished my presentation. If you have any questions, you can show me into the. Uh, yeah, I can share you the code later on our website. Yeah, maybe I will share the website. Um, but I cannot share with you the training data set because this is the private data set. You have to get your training data set by your own. Yeah.
So essentially what we did is we have this file here, and so I use PyCharm to do everything. It runs everything locally. So I don't use Google Colab. So just the same as before, we have to import all of our packages. And what we have to do in our case is what we are doing is we are classifying sentences in 10Ks, earnings announcements, and conference calls. And in these different data, they are not split into sentences already. So the first thing we have to do is split all of these files into individual sentences. And just like before, we have to define our model. So CUDA is the device that you say if you are using a GPU. So CUDA allows you to do things in 6 minutes instead of 60. If you don't have a GPU that is able to do CUDA, which is really only NVIDIA GPUs, then you have to run it on a CPU. So that's what this code is doing. And then what we're doing is we're taking each sentence within our split up document, and we are encoding or tokenizing each sentence. We are getting the prediction based on our pre-trained model, and then we're applying it. So the way that it looks when we're processing these files is we have a list of files to go through. We're opening up each individual file. We split each file into sentences, and then we get the predictions from each of those sentences. And then we create a data set with each sentence and its predictions so that then we can also go back later on and do some other textual analysis stuff. We could look at the tone, we could look at what types of words are being used in these. And then this function just says to loop through each of the files in the folder that we tell it to look in. So in this case, we have a folder that has all of the 10Ks that we downloaded, all the item 7s, item 1s, item 1As, and we loop through all of those and we create a new CSV file. And this is where we tell it where to go. So it's very similar code to what was shown before, but in this case, we're not pre-training the model, we're not fine-tuning the model, we're using the fine-tuned model. And then we're outputting the output of that model to a separate file that we can then aggregate and use to put into our analyses in the paper.